In this video, we're going to learn how to do calculations of solution stoichiometry. So here's a problem. Consider the balanced chemical equation. What volume of a 0.200 molar solution of HCl would be required to fully neutralize 100 milliliters of a 0.15 molar solution of CaOH2? So we're asked about the HCl solution, and we're asked specifically for volume. So I'm going to put in liters here as the thing that I don't know. And I know that my conversion factor to get there is going to have to do with the 0.200 moles per liter, which is my concentration. So before liters and using concentration, I've got my moles. And let's go, I guess we can keep going in this direction. We're asked about the calcium hydroxide. So I need a certain number of moles of calcium hydroxide. And do I have a measurement? Well, I do. I've got 100 milliliters, and the 0.15 molar is going to be my conversion factor to get there. So 0.15 moles per liter. And again, my starting point is 100 milliliters. So if I solve this, first of all, I'm just going to make things a little bit easier for myself. I'm going to say that 100 milliliters is equal to 0.100 liters with the right number of sig figs. That I will allow if you were to do the same thing. So you'll notice here, we don't have to worry about molar mass. If we're working with a solution in a problem like this, there is no molar mass required. So yay, we don't need to add those up. Now, let's just do the dimensional analysis and be done with it. 0.100 liters times 0.15 moles of calcium hydroxide for every 1 liter of solution. That gets us here. Now we need to go moles to moles. We need 2 moles of HCl for every 1 mole of CaOH2 times 0.2, sorry, doing this a little bit too fast, times, all right, we're going to liters and we've got moles of HCl, so we need to have 0.200 moles of HCl on the bottom, and on the top is going to be 1 liter. So just running through this, we have 0.100 liters of our calcium hydroxide. Our liters cancel out to give us moles of calcium hydroxide. Our moles of calcium hydroxide cancel out to give us moles of HCl, and our moles of HCl cancel with the reciprocal of the concentration that we've done here. And that gives us 0.15 liters of the HCl that will be required to fully neutralize the calcium hydroxide, I believe. Hope that one helps. Might want to check my math on that. So finally, consider the balanced chemical equation below. It takes 50.0 milliliters of a 0.200 molar solution of HCl to neutralize 25.0 milliliters of a calcium hydroxide solution. What is the concentration of calcium hydroxide? So notice that this is different because we have to solve for the conversion factor. And we haven't done that until now. So we need the concentration of the calcium hydroxide, and I'm just going to put in X moles per liter. You know, guys, that the concentration has to be, it has to be the conversion factor here. Now, how much calcium hydroxide is neutralized? It's 0.250 milliliters, or 25.0 milliliters, which is 0.025 liters, so 0.0250 liters. And I need, of course, moles, which I don't know. I know that I use, let's see, 50.0 mils. 1, 2, 3. So that is 0.0500 liters of hydrochloric acid. That can bring me to moles of hydrochloric acid if I know the concentration, which I do. It's 0.200 moles per liter, and that's moles per liter. And I also know that I got a 2-to-1 ratio, 2 to 1. All right, so from here, I can set up the dimensional analysis, 0.0500 liters times 0.200 moles HCl for every 1 liter times 1 mole calcium hydroxide for every 2 moles, so it's 2 moles of HCl. And so I get to this point, and now it's kind of weird because theoretically I could say times X moles, times 1 liter over X moles equals that 0.0250 liters. And I could solve for X that way, but X is in the denominator. It's actually really messy. So I'm actually going to stop here. I'm going to leave it at this, and you'll see why. It just makes it a little bit easier to solve. So I'm going to be at moles of calcium hydroxide, and what I find is that there are 0.005 moles of calcium hydroxide. From here, I can go into the definition of molarity. I know that molarity equals moles per liter, and I can use that to my advantage because what I can say is that my molarity is equal to my 0.005 moles of calcium hydroxide that I just calculated from here, divided by the 0.0250 liters that I have over here, and I can say that my molarity therefore is equal to 0.2, hold on, let me figure out the sig figs, 1, 2, 3 sig figs, nothing more than that. All right, 0.200 moles per liter. That is my final concentration. So these are 2 different ways of doing the same thing. 2 different solution stoichiometry problems. The previous case, we had to find a volume. In this case, we had to find the conversion factor, the molarity. Hope this video and these examples have been helpful for you. And let me know if you have any questions or comments in the comment section below. Thank you.